सो वेलकम गाइस। ये हमारी पहली वीडियो है जो हडूप के कोर्स में होगी। पूरा फुल हडूप का कोर्स करेंगे, ठीक है। और ये फर्स्ट इज लाइक एन इंट्रोडक्शन, और जिसमें आपको मैं हडूप के बारे में बताऊंगा। आई विल टेल यू अबाउट हडूप एंड द properties of Hadoop. This will be a full course and would be like a playlist. And these are my own handwritten notes, as you can see. And I will try to explain this Hadoop from my notes to you. सो लेट्स स्टार्ट। और ये नोट्स मैं आपको प्रोवाइड कर दूंगा मतलब अपने नीचे, मतलब कहाँ, डिस्क्रिप्शन बॉक्स में। ओके, सो लेट्स गो। ठीक है, आते हैं हम अपने फ्लो पे। आ जाइए। हडूप, व्हाट इज हडूप? हडूप इज बेसिकली एन ओपन सोर्स फ्रेमवर्क, ये जो डिजाइन टू हैंडल मैसिव अमाउंट ऑफ डेटा इन डिस्ट्रीब्यूटेड एंड स्केलेबल वे। दैट मीन्स लाइक इफ I have a very big data, let's say very large data of petabytes, okay, petabytes and terabytes. Like terabytes is small, petabytes I should write in a better way. Like I have a petabytes data, petabytes, I think how much it is. Let's search for a second, I forgot it. Petabytes, it is 10 to the power 12, I think so. 10 to the power 15. Like 10 to the power 15, I have data 10 to the power 15 bytes. Now to handle this amount of data, this and this volume of data, and what we do, we store this data in a distributed manner. Distributed means like I am storing this inside many nodes. Like if this is my master node, which was having the original data. Now it has sent its data, parts of its data to other nodes. It sent some part of its data to other nodes. As you can understand, like data is being divided and stored in different computers. Nodes is equals to computers, different machines, and in a scalable way, because if we want to store big data, and we cannot store it in a single node, single machine. So, and because it is not scalable means that we can expand. Here are two functions of Hadoop. First is massive data storage. Like I told you that if we want to store massive amounts of data, then we use this faster parallel processing. Like if you store your data in multiple nodes, then you can parallelly execute your task on data. It's like on the small amount of data on each node. On each node, I can perform my task. Let's say task is T. I can perform my task T on each node. With the smaller amount of data that has been distributed. Now let's quickly come to properties of Hadoop. Properties of Hadoop, first is scalability. Hadoop can scale horizontally. That means I can expand it from 1 to 2 machines to 3 machines to any number of machines I want. The number of nodes I'm storing my data on can be increased from 1 to 2 to 3 to n to 4 to 5 to 6 to n nodes. Let's come to fault tolerance. Fault tolerance means like let's say I have 6 machines. Which are storing my data. Okay, my data is, let's say, D. Now D has been divided equally or either unequally into these 6 machines. Okay, one of the machines has, now D has not been, we will not say divided. Let's say in our case, the data, it's the choice. Like Hadoop, you can do in Hadoop, either you can replication means like either you can divide, or better than division is what is actually happening is each node contains D data. The data has been replicated. D has been wholly replicated. Let's make it more simple. Like full D data has been given to this node, let's say, and the data has been replicated to this node, to this node, to this node, to this node, to this node. like each node has d amount of data, equal data. Okay, now in case any one node fails because of the replication, because we have made a copy of the data in each node, the system will still work. The system will still work. The system can still perform some task on the data. Okay, if two machines also fail, we still have four machines. If three machines fail, we still have three machines, as you can see. So that's the concept of fault tolerance. Third that is come is distributed processing. Like, what does it mean? Wherever the data is stored, no matter which node, the data D has been stored. Okay, each machine can do the processing on the data separately. Distributed processing means each machine can do the processing on the data. Okay, cost effectiveness. What happens in Hadoop is, instead of SDFS, or yeah, Hadoop or SDFS, like SDFS is a part of Hadoop. Hadoop does not require very expensive machines or very expensive like hardware to run it. You can run Hadoop on very cheaper or commodity hardware, like the hardware which is easily available, very easily available CPU, very easily available PC. You can easily like use that kind of hardware which is easily available and cheaper, and run Hadoop on it. Okay, open source, like it is free to use and modify. Hadoop you can download online for free. It is not paid, and you can modify it according to your needs, the configuration files on your system. Like you want something in Hadoop you don't like, you can edit the configuration of it on your system. It is totally up to your choice. Now Hadoop ecosystem, like what does Hadoop consist of? What all components does Hadoop consist of? Like so we will just see it. Hadoop ecosystem is a collection of open source projects and tools that work together to store, process, and analyze large amount of data. Now, first component that comes in it is HDFS, Hadoop Distributed File System. Now, distributed storage, as I meant, like let's say I have a very big data. Okay, D. Now, this data is stored here, due to replication, replication. Okay, now in different clusters. Now this is called a cluster, but the way the machines are together, all the machines are together, they are called cluster. Like the number of machines that I have, not number, like if I have more than one machine, it will be called a cluster. Okay, if I have more than one machine, like distributed storage, like no, I will correct myself, just sorry. Distributed storage is like, here we saw replication, let's forget it for a moment. Let's say I have data D and I have these nodes 1, 2, 3, 4. Now I don't want to store data D on a single machine. Then I can store D by 2 on some machine, D by 3 on some machine, D by 4 on some machine, D by 5 on some machine, and D by 6, like parts of the data. It's not mathematical like always, like again parts of the data on each node. Okay, so that storage becomes easier. And no machine gets overburdened. With data. Replication can also happen here also, like here replication was happening, the same equal amount of data here also can happen. What can happen is like this data D by 2 can have some similar data to the D by 3 data. Like in some sort of way replication happens here also. You don't take tension like replication doesn't happen here. This is a part that we will cover later, when data gets divided but still gets replicated. This is a part we'll cover later. Now second component is map reduce. Like what is that does is, like I told you how data is being divided. It processes data by breaking it into smaller tasks, task T, and that can run parallelly. Like it helps to run whatever execution we want to on the data to in parallel manner. Like part of the data, part of the data which is in replication D by 3, I don't know, sorry. like yeah, d by 3, let's say whatever amount of data it is, like the same data, like the distributed data across each node, like this has some data of the original data is d, this has some part of the data, this has some part of the data, and like this has some part of the data, this has some part of the data. Let me just make it above, you must not be able to see it, otherwise yeah, you can see it, you can see it, like okay, yeah, like this has some part of the data, this has some part of the data, this has some part of the data. Now we can now run it parallelly, each of them can start their operation parallelly without waiting for the other node, that this node won't wait for this node to finish its process before starting execution here, it will start to run parallelly. And you, what would we use, there is a technique that it will be used to do this parallel execution, map reduce. They will all do map reduce to execute this data processing parallelly. Okay, now third component is yarn, decouples the resource management from application execution. Now let's say you are, no, I'll just yeah, let it be like this only. We told that mr, map reduce, is used to run tasks parallelly on each node. Now let's say each node must have its own resource requirement, like this node wants some memory, some RAM to run this particular task. This node also wants something, this node also wants some resource, this node also wants some resource. To manage the resource, among all the nodes and split it among all the nodes, yarn comes into play and it does the job. So these were the three basic components of yarn, like Hadoop, HDFS, yarn, and MR, map reduce. Now let's see some other things also. Hive, it is a data warehouse. It's not a database. Data warehouse, it's like a query engine. Okay, it's like a query engine. What it does is, like, to implement map reduce, usually what happens is, earlier that developers used to write PSVM, like for a short Java code, if you know, many huge complex Java code to implement this map reduce, but now what Hive is doing, it abstract this code into like some basic, you can say template code. Into that template, SQL queries are being passed. Okay, into that template, SQL queries are passed, and the map reduce jobs are done without Java interference, and performance of map reduce is still kept. Performance of map reduce is still kept. So as you can see, the main motive to create Hive was to avoid Java code, and rather if we are keeping Java code also, it is like kept only one time as an abstract. We are abstracting the map reduce code, we are abstracting it, and like passing SQL queries into it to run the map reduce jobs. Okay, now pig, same, like instead of SQL, here is a different kind of language used, which is a high level scripting language called pig Latin, and it does the same job, avoids the Java and avoids the SQL code, but still keeps the map reduce task the same. Like map reduce happens here also, but rather pig Latin language is used. There must be a template of map reduce which takes the jobs from like pig or Hive in the form of pig Latin and SQL. Like the language goes into that template and performs a task, but it is the same, only that map reduce has been abstracted. The code, Java code, has been abstracted. Now there is no need to write Java code or SQL code. In pig, you don't have to write even Java code or SQL code, but Hive, you write SQL code for performing map reduce jobs. And this is not necessary that in Hive map reduce is used every time. We will see that later. But in pig, sometimes only SQL queries also work, but most of the cases like map reduce comes into play through the use of SQL queries. SQL queries like trigger the MapReduce jobs in Hive. You can say SQL queries trigger the MapReduce jobs in Hive, and pig Latin triggers the MapReduce job in pig. Now let's come to Scoop. What does Scoop do? Scoop facilitate import export between Hadoop and relational databases. Like you have a relational database system, MySQL database system, okay, inside your node. Now you want to export the data from it to your Hadoop. In that case, what comes into play? We use a tool called Scoop. Like we want to import data from Hadoop from our SDFS to MySQL, we will use Scoop. If we want to import data from MySQL to SDFS, we will use Scoop. Okay. I think import I said 2 times. One of them would be export. One of them would be export. I don't know what. Yeah, we want to export from Hadoop to, let's say Hadoop is our main and relation database is the other. So export from Hadoop to MySQL, Scoop. Import from Scoop to import from MySQL to Hadoop. Import from RDBMS to Hadoop. Here RDBMS is MySQL, so import from MySQL to Hadoop. We still use Scoop. Okay, a lot of repetition happened. Please, sorry. Kind of wanting to things that clear. I was wanting to clear the things for you and also for me. Now, what is HBase? HBase is a columnar DB. Like in here, data is not stored in the form of rows, but in the form of columns. Why it is used? Because let's say when data is stored in the form of rows, in the case of RDBMS like MySQL, what happens if you want to seek a particular record? If you want to know a particular cell inside this, you have to perform complex query using where conditions and sometimes group by and other things also. But in columnar, you can you can get it sometimes in a faster way. Many times in a faster way, because you're storing data column wise. Now you can directly access the record sitting, like whatever the column name is, you can access the record of that column directly to go by going to that column and a simple where condition. But if data is stored row wise, it is a little difficult. Okay, now what it is? It doesn't have SQL. Point to note here, this doesn't have SQL. No SQL database which allows real-time read and writes on SDFS. Real-time read and write on SDFS. Okay, like in RDBMS, if you have to do read and write, it will take some time. But in NoSQL databases, the time is significantly reduced because RDBMS has more abstraction and more security. But NoSQL databases have less abstraction, less security, which makes it like faster to read and write data. Flume and Kafka, it's I think a little bit complex. Even I don't have much idea about it, but it's a later part which we will cover later. It's like it collects the error logs, whatever error has happened in your program, or event data, what events happened in your execution when you perform the MapReduce task to form MapReduce technique to perform some task in your nodes. Then some errors must have been generated or some event must have been happened. So the data about these logs or events is stored in here, Flume and Kafka. Okay, real-time analytics, and it is used for ingesting streaming data. If you want to get the streaming data, it is used. Now there is one more, Zookeeper. Zookeeper is it coordinates distributed system to maintain consistency. What does it means? It ensures that each, like I told you about the node failure, that if any one node fails, we have 5 nodes, let's say, in our Hadoop system. If one node fails, each of them has a replication of the data. Now Zookeeper manages it. Now if this node fails, the other nodes still would work and perform the task, and a replacement for this node by replicating a data into a new node. These things will Zookeeper will manage. data management it will do. Critical for ensuring reliability among Hadoop clusters. That means like it ensures that all the clusters have the same data. There is no like difference in the data, like difference in the nodes. There is no difference in the nodes among the data. There is no difference of data among the nodes. Every node has the like same type of data only. It like consistency what it means same type of data. No node should have different type of data. Okay, and data should be like if any node fails, if any node fails to perform the task, the data should be replicated properly. Now this data can be d by 2 or something d by 3 or d by 4 or any, but it should be of the same type. No matter how much data it is still replicated in some way. You would say that equal amount of data means replication. No, no. If it is of the same type in some, and even if it is of the different size, like it's d by 2, d by 3, there is some sort of replication that is happening, that some part is going here, some part is going here. These two have similar kind of data. Like even if these two don't have similar kind of data, let's say d by 3 doesn't have similar data to this, but let's say d by 4 has some data of d by 3. Okay, let me explain to you. Let me give you some idea of it. Let's say you might have a point here, like if I have d by 2 data here, d by 3 data here, d by 4 data here, d by 5 data here, and d by 6 data here, you would say these data are not same in sizes. Forgive my handwriting. Okay, you would say these data are not same in sizes. So therefore it means like we should not say that they are replicated, but let's say d by 2 d by 3 are not similar, but d by 3 has been similarly stored in d by 6, and some part of d by 6 has been replicated in d by 3. Okay, some part of d by 3 has been replicated in d by 6, and some part of d by 6 has been replicated in d by 3. In similar way, d by 2 and d by 3 are not actually wholly similar, but some part of d by 3 is replicated in d by 2, and some part of d by 2 is replicated in d by 3. Like these kind of techniques are used to replicate this. These are the tension of zookeeper. Like zookeeper will handle the replication and fault tolerance in case of any system. When any system would fail na, when any system fails in our cluster, if let's say this system fails, these were like connected, I would say not connected, like working on some tasks, same task, but this system fails, still we can perform the task using other nodes. Because and if this system failed, zookeeper will manage that the data in these nodes get replicated in a new node, and it gets connected to the other nodes. Okay, and it gets connected to the other nodes. Critical for ensuring reliability among Hadoop clusters. Okay, so that they are consistent of same data, right? Now here is a little diagram I made so that you can either take screenshot of it, but I will provide the notes in the description. So as you can see, SDFS and HBase are used for data storage. Okay, MapReduce is used for cluster management. Like the more than one node is called a cluster. More than one node is called a cluster. Yarn is cluster plus resource management. Like any node which should get how many any node should get how much resources, resources should be allocated to a node, how much resources should be allocated to a node. This is controlled by yarn, like how much memory to give to, how much RAM, how much graphics to give to, like these are all handled by yarn. Now this comes under data processing, because MapReduce does the task of executing whatever is the operation with the data. Similarly yarn can also do, but we will see that later. Data access, like you want to access the data. Hive, query engine, pig, Avro, we didn't discuss, but not much in like talk. Scoop, I told you RDBMS to Hadoop connector. Okay, Uzi, workflow monitoring. Wflow is workflow monitor. Workflow is like how is the data workflow happening. Flume and Kafka, data ingesting streaming data, and used for like what it was used for. Uh, Let me just see. How did I forget? Sorry. Yeah, even logs and event data. Logs and event data is controlled by Zookeeper, management of data, fault tolerance, and kind of handling the replication also and everything. Handling how the data is like flowed from the client and the machines, between the client and the machines. Okay, between client and machines. Okay, now this was it. If you like the video, although my English is not very good, but if you like the video, if you like the notes, anything, just you can like the video and subscribe if you want. But although I upload useful content here, so subscribing is quite beneficial only, and share if you want. For now, I might upload more videos in today or night, in the night. But till then, bye.